Number 8. Number 8. All right, last one. This is a good one. Hopefully by now it's making more sense how to use mathematical thinking to quantify forces and acceleration. So how can we use Newton's second law? How can we use that equation as a tool for quantifying or finding specific values and numbers for the amount of force or the amount of acceleration an object experiences? In number 8, we have the same skydiver. That's our mass. And they land on the ground and slows to a stop. So already I can tell that this is an example that involves changing velocity, and I can add that to my annotations. The ground causes a normal force that is greater than the force of gravity, causing unbalanced forces so that she slows down. In that sentence alone, this is an example of how you would explain what's causing something to speed up or slow down. The main reason being that there's the forces are unbalanced, and it's clear in this sentence which one is greater than the other. We also have a diagram here at the bottom that shows that. In part A, it says the acceleration of the skydiver is 20 meters per second squared. Just pretend that that 2 is small and up above the seconds. So that represents meters per second squared. I know that that's an acceleration because those are the units. How much normal force? I'm trying to find a specific force, not the total force, but a specific force. How much normal force came from the ground? So I'm trying to find out how much this specific force is. So since I'm solving for a force, I can use this version of Newton's second law. It's the same equation that we used in number 7, but written in a way where force is by itself on one side. Now, just like some of the other examples, there's 2 forces acting here. And we know they're not equal to each other because the forces should be unbalanced because it's changing velocity. I can even add that here. Unbalanced forces. So on the left side of this equation, I'm going to have a mathematical expression that uses the symbols that we've been practicing using for normal force and force of gravity. And since gravity is going down opposite the normal force, I would write the expression like this. So even though there's no numbers, this is still an example of mathematical thinking because we're using subtraction to represent how you would account or add or combine 2 forces. The left side of the equation represents the overall force, the sum of forces. And on the right side, according to Newton's second law, that when we add them, on the right side should be something, a number that is given by mass times acceleration. So instead of writing mass times acceleration again, actually, I'll just do that and then start to add my numbers. Oops. So move this down. And I'm trying to find normal force. I do know how much gravity is acting on the skydiver because that was from the other problems. It's still going to be 700 newtons. The mass of the skydiver is 70, and the acceleration according to the problem is 20. So here I'm going to simplify in my next step. I'm going to multiply out the 70 times 20, and that comes out to be 1400. So what number, when I take away 700, will leave me with 1400? In order to find out, I can add both sides by 700 to take away this 700. And I'll find out that the final answer is 2100 newtons. That's how much force has to be pushing up on the skydiver when gravity's pulling down in order for the skydiver to have an acceleration of 20 meters per second. So that 20 meters per second means, 20 meters per second squared. That 20 meters per second squared represents acceleration, which means that she's slowing down. Or in this case, because positive acceleration, if you're moving down and you have positive acceleration, that actually means slowing down. So pointing up, the forces have to be stronger than the forces going down in order for her velocity to change. And the amount of upward force is going to be 2,100. Notice that's a lot bigger than the force of gravity. Force of gravity was only 700. So 3 times bigger in order for the velocity to change. If the normal force was the same as the force of gravity, she wouldn't stop. She wouldn't slow down. She would just crash into the ground and keep falling through it. The ground wouldn't be pushing back hard enough for her to actually change her velocity. That's Newton's first law. When forces are balanced, velocity changes, or the other way around too. If, I said that wrong. So Newton's first law tells us that if the velocity is constant, then there must be balanced forces. Or the way we usually write it, if there's balanced forces, there must be constant velocity. It goes both ways. But in this case, we have something that is changing velocity, therefore the forces must be unbalanced. That's all the problems in the study guide. You're about to get a small set of some more practice problems. Remember, success in this skill means understanding what actually is, what story is being told by this equation right here. Like what does each symbol mean, and how can we cleverly use this rule to find out unknown forces? This rule applies everywhere in the universe. This rule tells us that if we want something to go faster, we need to apply more force. Or if we want a larger thing to go faster, we need to apply even more force. If we're applying the same amount of force on something smaller, it's going to accelerate even more. So this applies everywhere in the universe. And part of what we're practicing is how to use mathematical thinking to make predictions about how much force or how much acceleration something is traveling in. The worksheet you're going to get has an answer key that's posted on Google Classroom. When you've had some time to work through it, you can log on and check your work. On Google Classroom, you can also post any questions you have on the answer key. You can just, if you have questions about the study guide, anything I went over, if you think maybe I made a mistake, or if you have questions, if your problems on your paper, because there's maybe the way yours was printed is different than what you saw up here. If there's something you're wondering about that, just add it to the Google Classroom so that I can see it. Maybe I can respond to it. If not, then it'll give us something to review on Thursday before you take your test. All right. Good luck and have fun today. Have fun.